Please wait while I prepare your meal.
So this is sort of a demo that we put together just to give you the idea of all the algorithms that are built in. You know, we're interested in building the fundamental algorithms of navigation, perception, and motion planning. And this task is just one of the many tasks that Herb can do. We're really motivated by tasks that can be performed in the home and can be performed in the home to help people, right? Both the elderly and the disabled. And you know, I'm thinking of all the things that my grandma has trouble doing, and I really want to try and automate some of these things so that her quality of life is certainly improved. So this is the personal robotics lab. I'm Sid. I'm a professor in robotics, the idea is to try and get robots out of the factory floor and into people's homes. And here's a little demo. This is Herb, short for Home Exploring Robot Butler. It's a robot that we built from scratch. And he's doing a very simple sort of meal preparation scenario here. And our goal is to try and perform useful tasks in the home. And we're part of the Quality of Life Technology Center, whose sort of mandate is to try and produce robots that can perform a lot of tasks that, for example, a caregiver in the home performs for you. And Herb here, I guess the thing to note is that he's working in a kitchen, and this is the same kitchen that we use. So we want a robot to work in the kind of environments that we work in. And this is sort of not a very comfortable zone for a robot, because robots are used to working in things like factory floors, which are built for them, whereas our homes are really built for us. And the task that he's performing is actually microwaving a meal and doing all of it completely autonomously. What we told him was, you know, here's a microwave, here's the meal, go find it and microwave it. He uses his spinning lasers, and these lasers produce about 40,000 points a second, uses them to build three-dimensional models of the world. He merges them with the CAD models that he has. He uses his camera to recognize and register objects, and uses his arms to plan motions so that he can accomplish tasks. You'll notice here that he's working in really tightly confined spaces that are actually pretty hard even for humans. And what he's using is both his base as well as his arms to figure out how to get to things, how to move to places. Also, you'll notice a lot of motions that he does where he uses his arms to sort of touch and feel around the space, using contact to reduce uncertainty. It's almost like you wake up in the morning and to turn your lights on, you sort of feel around and feel for things, and that's exactly what he's doing. Using not just his perceptual sensors, his vision sensors, but also his actuators, his arms, to try and figure out where things are. He's built on top of a Segway base. It's just this kind of same Segway that we ride on, except it's completely autonomous. And this is all custom built, and then his sort of big ticket items are his two arms. And these arms are anthropomorphic in that this is a shoulder, an elbow, and a wrist, just like our shoulders, elbows, and wrists. And one of the key things about these arms is that they're cable driven. So you see these little cables that are winding around the arm. Unlike an industrial manipulator, which is gear driven, it has big bulky gears everywhere. Gear driven arms are very precise. An industrial manipulator can go from one place to another with like micron precision. But if you're in its way when it's moving from A to B, it's just going to go through you. Whereas a robot like Herb, it's not as precise as an industrial manipulator, but it has whole arm sensing. It's very proprioceptive. It's sensitive to forces. And so this is really important to us because we want robots and humans to be working side by side.